Hope all you are doing good. So in previous lecture, we have studied new concept that is NPER. NPER means number of period, right? So we have seen several things where we were calculating future value. And for calculation of future value, we were using interest rate, we were using payment amount, we were using number of periods to find out the final value of future value. Now, when in future you will be solving practical cases or day-to-day life queries, so you will be facing such kind of problem where investor will be coming to you and he will be asking you that I want to invest this much amount, and after 10 years I want no, not after 10 years, he will say that I want this particular amount in future. So he will ask you that how much time is required to receive that much amount in future, right? So here we have to learn about NPR. So in Excel it is very easy to calculate, so we will learn NPER formula by using Excel. So concept I have already taught you in previous lecture. Now we will see one case. So here case is given. If you read the case carefully, so you will get the idea. 1 month from now, Morris will make his first monthly contribution of $250 to TFSA. You can assume it as a LIC. Over the long run, he expects to earn 8% compounded interest annually. Here he's making monthly investment and he will be getting interest that is annually compounded. How many months will it take for the end of the month contribution and accrued earning to reach $1 lakh? So I will draw a line diagram for you so it will give you better clarity. Here, what Morris is trying to do, he is trying to invest $250 every month. It is a monthly investment. And he is asking you that what number of period it will take to get $1, right? How much time it will take to get $1 if he's making $250 investment every month, right? Now, if you see here, if I talk about interest, so interest is compounding annually, right? Here, interest is compounding annually. And if I talk about payment or contribution, so they are making monthly payment. They are making monthly payment. Now, in previous cases, we have already discussed there should be a balance between interest and payment duration, right? So here there is a difference in interest and payment duration. Interest is getting accrued once in a year and Morris is making 12 payments in a year. So I have already told you that payment duration should be equivalent to interest duration. So what we will be doing, we will be converting this interest duration that is compounding annually. So it is 1 equivalent to 12 payment duration, right? So here what I will be doing, I have already told you the formula. If you want to find out equivalent duration, so it will be interest divided by contribution duration, right? So here interest duration is 1 and contribution duration is 12. So this is how we will be finding out the value for square purpose, right? We have to use another formula and we have to find out the square value, right? Square, not power value. So if you see, we will solve this question and automatically you will be able to understand. So nominal annual interest rate is 8%. Then after, if you see compounding per year, so interest is getting compounded once in a year. So we will write here 1. Payments per year, we are making 12 payments. Morris is making 12 payment. Regularly annuity payment amount. So Morris will be paying $250 every month, right? Present value is 0. Future value, how much amount he wants future? So definitely it is given $1 lakh. So he wants $1 lakh. So PV is going to be 0 and value is going to be 1 lakh here. Right? He wants $1 lakh at the end of period, right? So we have to find out the period. So it is 1 lakh. Now here, if you see, we have to calculate this equalized duration. So how we will calculate equalized duration? So interest duration divided by payment duration I have to do, and here I will get answer that is 0.0833. Now periodic rate, we have to find out effective rate, right? So we have to use the same formula which we were using in lecture 1, plus we have to take interest rate, right? So it is compounding once in a year, so we have to divide it by 12 or right? So we will taking interest here. Now we will be using which power we have to use or exponent we have to use. This exponent we have to use because here we have equalized period, right? So we are using this power and we have to reduce it by 1. So this is going to be your interest rate, or you can say effective interest rate, right? This is your effective interest rate, right? That is 0.0064340, right? Here this is effective interest rate. Now, if I want to find out NPR, so I will be using the formula NPER. Open up the bracket, we have to select the rate. So this is your effective interest rate. Now PMT, so PMT we have already written here, that is minus 250. Then present value is 0 right? Then future value, it is given here, that is 1 lakh. And we are making investment at the end of every month, right? So interest will get accrued at the end of every month. So here I will zero and I will press enter here, right? So it will take 198 periods. So your periods is 198. It means after 190 period, after 198-month duration, he will be able to receive $1 lakh. So you have right now 198.5 months are required, right? So every month he has to invest $250, and how many months it will take to get $1 lakh? It will take 198.58 months.